Now we will see how to arrive at the field sizes for each of the operands in case of non-restoring division. So as in the case of restoring division, in case of non-restoring division, the Q field, that is the field that holds the dividend, and the B field, the field that holds the divisor, both are supposed to be of same size. Let us assume that they are of size n. Then the A field, which holds the partial dividend after a shift operation, it is expected to be of size n plus 1. So let us first fix what is n, that is size of Q and B fields. So as usual in case of restoring division, the logic is it should be of the greatest size. It should be of at least the minimum size to hold the greatest of either Q or B. So let's see our Q and B. So here in our case the dividend is 23 and your divisor is 3. So our dividend 23, it requires how many bits? It requires only 5 bits for representation, and our divisor 3, it requires only 2 bits for representation. Then as in the case of restoring division, occasionally we may need to subtract the divisor from the dividend or the partial dividend. So if 3 can be held in 2 bits, then negative 3 can be held in minimal of how many bits? 3 bits. Okay, so if you see here, the negative 3 has to be applied on A, right? So if you fix Q and B as of each of size 5 bits, why? Because Q is already your 23, which requires 5 bits. 3 is just 3 just requires only 2 bits, but it has to be kept in the B field. It is given equal size as that of the field, that item in Q field. So it is fixed as 5 bits. So Q and B are set as 5 bits. But in case of our minus 3, right, it has to be operated upon A, which is of n plus 1 in size, or which is of size 6. Okay, so minus 3, even though it requires only 4 bits for representation, we use a 6-bit representation of minus 3 for operation. Okay, so this is how we fix the size of the fields of operands in case of non-restoring division.